This is our home planet from outer space. Look at it. You can't see the nations or the cities. You can't see the people, but if you look closely, you can still see life. That's what this green stuff is. Plant life. Life that makes other life on Earth possible. See, life on Earth probably wouldn't be possible without this green stuff. How all that happens is what it means to be green. The plants on Earth take care of the rest of us on Earth. Plants use a gas in our air called carbon dioxide. Without plants to absorb it, there would be more carbon dioxide in our atmosphere. That could make Earth warmer, perhaps warm enough to really mess things up. Plants behave like solar-powered chemical factories, making the food they need to grow, the food we need to eat, and the air we need to breathe. This plant is a factory. So is this one. And this one too. Lettuce does the same thing as wheat. Palm trees and pine trees do it too. Tomatoes, tomatoes. Potatoes, potatoes. We can use this factory to show you how plant factories work. Chemical factories make chemicals by taking apart molecules, separating the atoms, and putting them back together again into new and different molecules. Atoms are building blocks of matter. There are more than 100 different kinds of them. Groups of atoms stick together to form molecules. A molecule of something, say water, is the smallest chunk of water you can have and still have water. One molecule all plants make is a simple sugar called glucose. Glucose is made from 3 different atoms: carbon, oxygen, and hydrogen. Plants need glucose to grow and to make the energy they need to operate. To get the atoms in glucose, the plant takes apart water molecules and molecules of carbon dioxide. Carbon dioxide, or CO2, goes into the factory through its leaves. Water, or H2O, enters the factory through the roots. All the systems inside a plant are bathed in water. The water then takes an elevator ride up the stem in channels called xylem to the processor, the leaves. The water meets up with a chemical already in the plant called chlorophyll. It's the deep green color we see in plants. In sunlight, chlorophyll does this really strange and wonderful thing to H2O. Chlorophyll unbalances the water molecules, and they break apart into oxygen and hydrogen atoms. Oxygen, the stuff we breathe, is released from the factory and pushed out through the leaf. Meanwhile, the hydrogen joins the carbon dioxide to make new glucose molecules. The glucose takes an elevator ride down the factory to the rest of the plant in channels called phloem. This whole process is called photosynthesis. The word photo means light, and synthesize means to put together. The plant uses light to build the glucose it needs. That's photosynthesis, chemical making powered by sunlight. The product is glucose, the same sugar that all plants and animals use for energy. The big difference between plants and animals is that plants make their own glucose and animals get it from someplace else, a lot of times by eating plants. Plants use glucose just like animals do, for energy. All this growing and reaching takes lots of energy, and the plant gets energy from burning the sugar glucose. Animals use sugar for the same thing. Changing sugar into energy is called respiration, for plants and animals. Plants also use glucose or sugar as a building block. They put glucose molecules together to make a more complicated molecule called cellulose. Cellulose is the main stuff that plants are made from. Short chains of cellulose make plants that can bend easily, like these stems. Other plants, like bamboo, make long and strong chains of cellulose. Tree trunks are just really big stems made of hard cellulose. These stems are called wood. Some stems are completely soft because they don't need to hold up the plant. Sometimes we can take stuff out of stems. There's lots of sugar moving around inside these maple trees. We can pound a tube into the stem and collect the sugar. It's what we make maple syrup from, sweet tree sap. Some stems are warehouses and hold chemicals for the plant. Different plants make different chemicals, and these different plant chemicals create distinct plant flavors. That's why these plants all taste different to us. Some stems behave like leaves. The stems of cacti are the places where the sugars are made. It's also the place where water is stored. Stems take things up and down inside the plant and hold up the business end of this chemical factory, the leaves. Leaves are the solar collectors and the places where most of the chemicals are made. They are the power station of the chemical factory. Here's a microscopic photo of the top of a leaf. Each of these little holes is called a stoma. They are the doors into the leaf for carbon dioxide and the door out of the factory for oxygen and extra water vapor. These little doorways open and close as the plant needs more raw materials or has more waste oxygen or extra water to get rid of. Water vapor can also escape from these holes. We call that transpiration. When a plant hasn't been watered and the leaves wilt, the water has escaped right through the leaves. Leaves come in all shapes, sizes, and patterns. Each shape and size works perfectly for that plant where it lives. We call this a lawn, but it's really thousands of plants and thousands of leaves together. Some leaves are long and pointed. Some leaves are sharp needles. Other leaves are huge and wide. We even eat many leaves, like lettuce, or spinach, or kale, or cabbage. There's lots of chemicals in leaves that create different flavors and different colors. Some leaves have such strong concentrations of flavor chemicals, we can use them to flavor our foods. We call them herbs, like basil, mint, oregano. Other plants, like this skunk cabbage, make really smelly chemicals to protect themselves from being eaten and destroyed. The chemicals in other leaves are fragrant and pleasant and make, well, a great cup of tea. When the days get shorter in autumn, some leaves go through some really big changes.
Oh, I just love it when the leaves change color.
Grandma, they don't really change color, they lose a color.
Lose a color?
They lose the green.
Precisely, precious. They changed. Oranges and browns and yellows, like a beautiful quilt that...
Those colors were already there. You couldn't see them with all the green in there.
Green?
They're chlorophyll. They need it for photosynthesis.
Don't slap, dear.
See? These plants are shutting down for the winter, so they pulled their green chlorophyll out of their leaves. The autumn colors you see were always there, so the leaves did not change color. They just lost one. Green.
It leaves the leaves because it's too precious, I guess. More tea, precious? I think it's green, too.
Whether they're tea leaves or tree leaves, all leaves are supported by these structures below, the roots. Roots are the way that most plants get their water and minerals. Roots also anchor plants in the ground. Sometimes roots grab onto things that aren't the earth. This plant doesn't grow in the soil. Its roots grab onto trees or rocks and hold on tight. Some roots are also warehouses, places where the plant stores the chemicals it made or needs. These warehouse roots swell up, and we eat many of them. There's lots of glucose sugar stored in these roots. Some roots even put minerals back into the soil. Bean roots return nitrogen to the soil. The plant got it from the air we breathe, but then again, they're chemical factories, and they can do stuff like that. Roots help hold the earth, too. The soil stays in place, so the winds and rains don't wash it away. We even use the word root to mean essential. When we get to the root of a matter, we get to the central important thing, which is pretty much what we've done here. Now you know that every plant is a factory that uses water, sunshine, and carbon from the air to make glucose, that plants use glucose to build themselves, that without the oxygen plants give off as waste, Earth wouldn't have breathable air, and that plants storing carbon is an essential part of the life cycle of Earth. Earth wouldn't be able to support animal life without green plants, animal life like, us humans, and penguins, Guernsey cows, big fat sows, buzzing bugs, and every other creature that walks, flies, crawls, or creeps. So the next time you see a plant, say thank you.